Hi everyone, in this video I'm gonna present our big data analytics project, Yelp data analysis and recommendation. Our team members are Lan Yang, Hongyang Bai, and Yazhuo Nan. The data provided by Yelp datasets gives a significant amount of information related to business around different locations, users all over the US. With the given data, we build a recommendation analyzing system to provide top selections for the user in a typical region or with their ID. We put all the result data into Amazon RDS for storage and show the final results by a small web application we created. In order to get results, we consider various data attributes, such as business ID, name, and locations, in the business.csv file and also the check-in.csv file, to obtain the user's check-in information for a typical business. The dataset is provided from the Yelp Dataset Challenge. It has over 40,000 business and 250,000 users and 1.12 million reviews, spanning multiple cities. There are 5 files contained in this dataset, and we only chose 3 of them. They are business, check-ins, and reviews. We concentrate on the major attributes such as business ID, name, city, state, longitude, latitude for the business table. Check-in time, business ID for the check-in table. User ID stars for the review table by joining them via the key attribute, business ID and user ID. The system structure can start with the Yelp datasets, which is in JSON format. We first pre-process the data into CSV file and input them into either Spark SQL and Spark recommendation algorithms. The results are stored into Amazon RDS database, and the Flask backend web application uses the data provided from the Amazon RDS to show the data as the front-end web page. For the algorithms part, user-based recommendation is determined using Spark machine learning library, which includes the implementation of alternating least squares. The ALS attempts to estimate ratings matrix R as a product of 2 lower rank matrix. Feature vectors, which are the dot product of user's vector and the product vector. Solving the factorization involves messenger passing between 2 feature matrices via their iterative process using least square with regularization. So the key formula in this algorithm is the formula presented in this page. It has a regularization term to prevent overfitting problem. There are a couple techniques using our project. First is Spark SQL, which lets you to query structured data into the Spark program. We used Python combined with SQL for our project. The inputs are joined CSV files. The Spark SQL is aiming for building tables for each file and using SQL phrases to deal with all kinds of data to get what we want from future analysis. Spark machine learning library consists of common learning algorithms and utilities. For the purpose of the project, we only use collaborative filtering. Flask web framework we use for a web application. The Amazon RDS, which is as relational database services, provide multiple datasets engine in the cloud. We use MySQL as our backup database. For the future work, we aim for the accuracy, since the dataset is sparse, to little set of same business IDs are viewed by different users. Therefore, if there is a more dense relationship between users and business, we would train more accurate model to gain recommendation results. There is still much more to explore with the datasets. For instance, the typical review of a user for a restaurant, and also their friend's ID information, which may contribute to explore whether or not they have a common flavor over restaurants. Or evaluation could have a positive effect for users to explore the business around the location they arrive. For the demonstration, I'm going to present our web application. On the left of the page, as you can see, we have a Google map presenting the heat map distribution. In our example, we have 2 cities for the demonstration. One is Las Vegas, the other is Henderson. As you can see, the heat map presents the distribution of check-ins for different time period. For example, on the left right now is the heat map of the check-ins around the time from 8 o'clock in the morning to 9 o'clock. If I change the time period to 12 to 1 o'clock around the noon time, we would have a different heat map. If we input the time period at the late night, we would have a less dense heat map. But in general, the heat maps are pretty much the same, meaning that Las Vegas has always intense activities across the day. In order to make a comparison, by changing the cities from Las Vegas to Henderson, which is a small town near the Las Vegas, we can see that it has a much less dense heat map. But for the noon time, we see that activity are much more compared to the middle of the night. The other feature for our web application is recommendation system. There are two kinds of recommendation. The first is user-based recommendations, and the other district-based recommendation. By giving a user ID on the top of the page and the address, we would have a district-based recommendation of restaurants. And if we choose a different address, for example for Las Vegas, and click recommend, we will have different restaurant recommendations in Las Vegas. The other part is the user-based recommendations. The results are obtained from the user ID along with their reviews from the Spark machine learning libraries. Thank you for watching.